Hello, everyone. Can you hear me? Please leave some comments if you...
Can you hear me?
I can hear myself now. Hi, Gustavo. Can you hear me? Yes, good. Okay, I guess we can start. So, welcome to our workshop, September edition. Oh, yes, so many yes. Good, good. So, this workshop, we will introduce DLT fundamentals. For example, we will tell you about sources and resources, how to build your DLT pipeline, how to make it incremental, how to use Filesystem as a destination and as a source. Also, we will teach you how to debug your pipelines, how to investigate your schema and metadata. So today with me will be my precious colleague, Anun. Please welcome her. She built half of this workshop. Anun, do you want to introduce yourself?
Yeah, thank you. So once again, I'm Anun. I'm a working student at the ELT Hub focusing on data engineering, and honestly, I'm quite happy to be one of the speakers at this workshop because I was introduced to data engineering with DLT itself, and it's been a great way to learn DLT/data engineering fundamentals because DLT itself represents data engineering best practices, and it's like a all-in-one solution. Yep. So I'm gonna start with a small introduction presentation. So I'll be sharing my screen. Yep. Can you see the presentation? Okay. So let's start with a quick overview of what DLT is, or the data load tool. Yeah, we're gonna go through this amazing presentation. It has a lot of memes, so I hope you guys enjoy it. We'll first explain what ELT is, that is extract, load, transform, then explain what DLT itself is, and explain the reasons why you should be using DLT. So to start from the beginning, what's data engineering at all? And in order to explain that, we need to know what the ETL process is. It's the extract, transform, and load process, and data engineering is about handling all the problems that arise during the process, starting from, having to explain why transferring data from one source to another destination is not a piece of cake, and having to deal with AWS permission hell. And perhaps you noticed from the previous slide that we're mainly try to use the term ELT instead of ETL in terms of DLT because the library itself is designed to support ELT operations, meaning although it does let you use some kind of transformations, its primary goal is to simplify the extract and load steps, thus ELT, not ETL. So back to data engineering. A random data engineer wrote on Reddit, "I'm a plumber. I pipe data from one place to the other and make sure it's clean for the business to use." In other words, data engineering is something not everybody is willing/likes to do. And no offense to data data scientists with this meme, but the reality is that every data job is a data engineering job. But the thing is that not everybody is a data engineer, or simply enough, not paid enough to be one. And obviously the solution is DLT because, we're all here for it after all. It's budget friendly because it's open source. It scales well because there are many integrations. They're regularly tested. and it's Pythonic, meaning DLT is not a UI black box, nor is it some assembly code impossible to learn. I mean, maybe there are some people who can assembly code, but yeah, there are not many of them probably in this workshop at least. Okay, what is DLT? Once again, this is an open source Python library that you can install with pip. It automates complex tasks like schema evolution, data normalization, and incremental loading. And much like dbt democratized the transform layer of ELT for SQL users, DLT democratizes the the extract load steps. So why use this tool? I mean, at this point, it must be quite obvious since I've been repeating these points multiple times now, but the bottom line is that it's super easy to use. I mean, look at this code. This is like how many lines of code? 6, maybe 3, if we, put everything here in one line. And this is the code you can use to transfer data from one destination to another. This is a full-on pipeline. Yeah, and as I mentioned right at the beginning, DLT feels like a pack of data engineering best practices all in one. It handles schema evolution, so you don't have to manually define it each time something changes. It has data contracts, which help preserve schema integrity. And it supports incremental loading because, I mean, it's a must. It's the holy grail of data engineering. And it provides performance management and scales up pipelines, saving you time and money because time is money. To wrap this up, there's a whole DLT ecosystem. There are DLT verified sources and DLT destinations. The combinations are regularly tested, and there are base projects you can modify to your own needs, letting you starting your data pipelines in just a few minutes. So these are all linked. So we encourage you to go through this presentation once again after we finish. Yeah, and now let's slowly go to the workshop itself. These are the topics we'll cover, and I'm gonna switch to the Follow Me collab. Yep. Is the text big enough? Or should I?
Yeah, there is a small lag in comments, so
Okay.
you can avoid. Yes.
I guess it doesn't hurt to. Okay. Okay, I'm gonna just show the GIF. Okay, so the general outline on this workshop collab is that we're first gonna load data to DuckDB, then configure a pipeline to load data into the local file system instead of DuckDB, and finally learn how to use the file system destination as a staging storage using S3 as an example. This will be covered in a separate collab. And okay, please pay attention to the word learn here, because we won't have you do this third step in this workshop, but rather show you how to do it so you can test it on your own if needed. This is because it involves some not so beginner-friendly AWS services like S3 and Redshift. Yeah, so you can try it later. In the process, we will cover these topics. They were also shown at the end of the introduction presentation. You don't have to dive into the details of the names right now, as we'll cover them one by one. Okay, now you might be a little confused about the structure of this workshop, and let me explain. The current collab, Follow Us, Exploring DLT Fundamentals, is the main collab you'll be using. And throughout this collab, there will be small sections where you'll need to fix or complete code. And these sections will explicitly begin with a very noticeable to-do, like this, with 3 emojis. And what you need to do right now is to make a copy of this collab and have your GitHub access token ready, like this. I'm going to give you 1 minute to have this, and we're going to continue. And as we progress, we'll encounter links to additional collabs, each covering different aspects of DLT fundamentals mentioned earlier, meaning these ones here. And they will help you complete the to-dos, so follow them closely and pay careful attention. Yeah, 1 minute. I'm assuming it's almost up. Yeah.
Maybe you should show again how it should look like.
The access token?
Access.
Okay.
Yeah. Access token.
Yeah. Okay, just to know, you don't have to have all of these, just access token. Yeah. Okay, I think 1 minute is up. I'm going to continue, right? Okay. Now, before diving in, let's first try running a simple pipeline with DLT resources and sources in the Getting Started collab. We're going to click on this one. You don't have to run the code with me in this one. I'm just going to explain everything in detail. So here we will run a simple pipeline with toy data and learn how to explore the loaded data using the Streamlit app integration or use DLT SQL client, and then learn how to use DLT resources, also transformer resources and sources. First, we got to install DLT with DuckDB. Then we'll find a list of Python dictionaries, which we'll use as toy data. Okay, now this one has Potter and Hermione with ID. Okay. Is it good? Okay. Now the data is a simple Python dictionary. This will be directly passed to the pipeline. Just note that for now. And we need to import the DLT library and define our library with destination as DuckDB, and got to give a name to our data set, my data, and give a name to our pipeline, quick start. How we run the pipeline is to use this code here. We just read pipeline.run, pass our data, which we defined earlier, and give it a name because we're using Python dictionary. And we see that when we run this code, we have load info, which has a load package, and there were no failed jobs. What happened is that DLT created a schema called MyData, the name for which we provided here, with the table students, the name for which we provided here. And it stored data in the database. So how to view this data? Now there are two easy ways to view your data, either using the Streamlit app integration or the SQL client. Okay, to make things clear, the Streamlit integration doesn't really work well in Colab because it's not easy to access the local host from here. So I encourage you to try this locally. This is just gonna include some code. And if you try this locally, I'm sure there's gonna be no problem because this is super easy. So what you gotta do is install Streamlit and run this command, DLT pipeline quick start show. Note that quick start is the name of your pipeline. And as a result, in your terminal, you will have something like this. And you go to the link and it will open the Streamlit application, and you will be able to see your data, something like this, the quick start schema with table students and data with Harry and Hermione. Okay, the second way to view your data is to use the DLT SQL client. What you gotta do is start a connection to your database with pipeline.sql client and execute a query. Here we're just selecting everything from the students table, and we see that it's exactly the same data that you will see in the Streamlit application. Here, we're just playing around with the code and counted the number of students in the database, and the number is 2, Harry and Hermione. Okay, now we'll cover DLT resources and sources. This is personally, I think, one of the most important things to know about DLT, because without this, you won't really be able to use any DLT features that are important for the whole data engineering space, profession. Okay, so in the previous section, we simply used a list of dictionaries, right? Which was this. And now we're gonna wrap it in a DLT resource decorator, which denotes a logical grouping of data with the same structure. So as you see, here's the data. We wrap it in the myDict list, which is using the DLT resource decorator. And the function here is yielding the data. And that's it. And we're providing table name new students because we want to add them again. And note that if we do not provide a table name, the table that is going to be created from this function will take the name of the function itself, meaning the table will be myDict list instead of new students. Okay. So we run the pipeline by simply passing this function to the pipeline run. And that's it. As you see, it was successful. You can see if it really loaded anything. We're using the SQL client here. We're selecting everything from the new students table, which was associated with this function here. And we see that, yes, everything was loaded successfully. Now, instead of a Python dictionary list, the data could also be a data frame, a database query response, and an API request response. In this example here, it's the same data, Harry Potter and Hermione. But we're wrapping it in a data frame just to show that you can yield data frames, and you can also wrap it in a DLT resource decorator, give a name, define this function, and pass it to a pipeline. It's going to be the same thing. For database query responses, you could do this. This might be a little bit confusing because it's not Harry Potter or some explicit data. We're using a public database connection string here, so don't worry about this. What we're doing is connecting to this public database and querying the genome table and just yielding the mapped version of the response. And for API endpoints, maybe some of you are already familiar with it. We're just sending a request to the API endpoint, receiving response, and yielding the JSON of that response. Now, what we're going to do is that we're going to put all of these functions, get issues, get genome data, my data div, into a list and pass it to the pipeline run. And we see that everything was loaded successfully. I guess a little bit strange that we'll load Harry Potter and Hermione in the same database as this data with genome data, but yeah, it's just for demonstration purposes. Okay, and we can query the database and to see what tables it has now. And we see that there is data frame data, genome data, GitHub issues, and child tables that were created from the GitHub issues table this year, and the previous tables that we created from the basic data of Harry and Hermione, new students and students. Now that the last three tables are internal DLT tables, and you don't have to worry about them right now. So we've covered DLT resources, each corresponding to a separate table, and we can group them in a source. And source is a logical grouping of resources. And why you have to do this? It's more efficient than running your resources separately. It organizes both your schema and your code and enables the option for parallelization later. This topic will be covered in the second part of the workshop, and it's quite important. So how it's done? You will just use the DLT source decorator and return all resources. And exactly like resources, you would just pass this function to the pipeline run. That's it. Okay, the last part of this collab DLT transformers. We now know that DLT resources can be grouped into a DLT source represented as this. But however, imagine a scenario you need an additional step in between, right, where you do some transformations. This step could arise, for example, in a situation where resource 1 returns a list of user IDs, and you need to use each of those IDs to retrieve detailed information from a separate API endpoint. And in such cases, you would use DLT transformers, meaning this step is just a transformer itself. And a DLT transformer is a special DLT resource that can be fed data from another resource. So how you would use them is that, let's assume resource 1 is this. We've already used this before. This is just yielding Harry Potter and Hermione data. We need to get detailed information about Harry Potter and Hermione from the Harry Potter API. So this API, when you pass an ID, it gives you detailed information. And what we do is we define a DLT transformer. Yeah, the decorator here. We define data from my dict list, which is this one here. And we provided a table name, detailed information. And since it's getting data from my dict list, means it's getting the whole of this. So for each dictionary in data, it's getting the ID, this part, and then passing it to the API endpoint. That's it. And in the pipeline, you would just call the details transform itself, and everything will be loaded. As simple as that. Alternatively, what we could do is that we could yield each record separately by yield from, not the whole thing, but first yield Harry Potter and then Hermione. And then we would define the transformer just with one data item, not the whole thing. Meaning, during the first call, it will receive the Harry Potter and get the ID, call this endpoint with Harry Potter ID, get the response and yield detailed information only in Harry Potter. And on the next call, it will receive the Hermione's ID. Yeah, and this is it. And we can check if we loaded everything, and we see that yes, there is a bunch of information about Harry and Hermione. So this is it. Let's go back to the follow us collab and install DLT with DuckDB as our destination. You have to follow this collab though. Now that DLT is installed, let's define our first DLT resource. I mean, it's already defined here. It fetches GitHub issues from our repository. And there is the pagination function already provided. It repeatedly retrieves each page of results until no more pages are left. And let's add another DLT resource that uses the Stargazers endpoint of the GitHub API. I feel like my voice is dying. Let me take a sip of water. Yeah, pay attention to the fact that we're retrieving 50 records for each API request. Okay, and our third DLT resource is the pull request resource. You see that it follows exactly the same structure, just has a different table name and different resource function name. Yeah. So now the to-do part. What you gotta do is to wrap these 3 resources into a single source called GitHub Data. I'm gonna give you a minute.
Because I'll ask, make it slower if it's possible, but if it's not, just do as you prefer.
Okay, I think a minute has passed, so I'm going to provide a solution. If you've managed to do it, let us know. If you haven't managed, also let us know, but I'm going to give you the solution. So I'm using, actually Google Colab AI is working, but yeah. We're going to use the source decorator here, and then we're going to define the function GitHub Data, and we need to return the resources. Yep, let's run it. Okay, and now that we've grouped the resources into the GitHub source, let's move on to creating the DuckDB pipeline. We give the name GitHub Data DuckDB and specify the destination, DuckDB. Quite intuitive, I think. We run it. Okay, the pipeline is now created, and we run it with duckdb.run and pass the source to the pipeline run. This may take a while, and while it runs, you may ask questions in the chat. Okay, successful. No failed jobs. Let's go check if everything's loaded. Yep, the DuckDB database is here. Let's now check the tables that were created in the DuckDB database by using DLT SQL client that we've covered in the last collab. Okay, don't mind this code. This is just adjusting the display. Let's run this. And yes, we have the issues table, the pools table, and the stargazers table. And now you might be wondering, what are these? These are the child tables that were created from the parent tables. And this was done by DLT's normalization engine that unpacks nested data structures. So this is done completely automatically. You don't have to define anything. So let's now print the last normalization trace. This is basically how many data rows pass through the normalization engine of DLT. And we see that, issues, 165 rows, pools, 26 rows, and stargazers, 2,321 rows. And in total, this is about 2,500 rows. And remember that we set the per page data row to 50, meaning 2,500 divided by 50. We have 50. We've made 50 separate API endpoint request calls. Now, in order to continue with this collab, we have to provide the access token to DLT, because GitHub API has a rate limit of 60 requests per hour, and to and to get past this rate limit, we need to, as I mentioned, provide the access token. And to do that, we need to first go through the defining secrets in configs collab. So here, you will learn or brush up on how to add values to secrets toml or config toml and use environment variables. These are the two main ways how DLT manages sensitive information. So to put it out there straight away, Colab isn't really suited for DLT to use toml files because the concept of the Python file that has your pipeline code, I mean, this one here, doesn't directly translate to Colab's virtual environment. So I'm just going to show how you can do it locally without running any code in this specific part. Now, let's say you have your pipeline code in this file, my pipeline code. And on the same level, there should be a DLT folder where DLT expects the toml files to be. If you initialize the project with DLT init, this folder should already be there. But if you're writing your code from scratch, you can manually create this folder and add the toml files there. Now, assume you have your my pipeline code ready. And this should be familiar because we just used it in the main Colab. And to pass the unauthenticated rate limit, we need to provide an access token, which we do not want to specify directly in the pipeline because who specifies access tokens in the code? What we'll do is, what we would do in the local environment is to add our access token to the secrets toml file like this, and then adjust our get issues resource so that it accesses this value. What happens here is that dlt.secrets.value will resolve the access token with the actual secret value provided in the secrets toml file when the pipeline is run. And obviously, we need to pass this access token to the pagination here and adjust the pagination function accordingly because the pagination function is sending requests to the API endpoint. And note that DLT config.value is similar to DLT secrets value, but the only difference is that it tries to access the config.toml instead of the secrets.toml file. Yep, that's the only difference. And the second way DLT can access secrets is via environment variables. We simply define environment variable like this. You don't really have to pay attention to the Google.Colab thing because it's just retrieving your token from this here, and you define an environment variable access token, and you don't even need to change anything in the resource because DLT secrets value will look for the access token first in the secrets toml file and then among the environment variables. So you don't have to specify that it's an environment variable. And then you would normally create the pipeline and run it. There are no fail jobs, all good. And here we just checked if everything was loaded correctly. And yes, 167 issues. Alternatively, we could explicitly set the access token with DLT secrets like this. Yeah, this is just another way to save your token. This is basically doing the same thing. And as a last note regarding secrets and configs, the naming convention of environment variables is perhaps the most important thing. Note that sections are separated by double underscores, meaning if you have something like this in your secrets or toml file, destination.filesystem bucket URL, then the equivalent environment variable will be everything capitalized, destination, double underscore, file system, and double underscore bucket URL. And these two are equivalents. Okay, that's it. Let's go back to the follow us collab and continue running our code. So here we're saving environmental variable access token. Here we already adjusted the pagination function so that it uses an access token and sends a request to the endpoint with an access token. What you gotta do is adjust the resources so that they are able to access the token and pass it to the pagination. 1 minute.
You can tell a joke for a while.
Yeah, actually, yeah, these 1 minute breaks are quite awkward.
Open a list of dead jokes. Yeah.
Okay, just saying, if you've been following the last collab, this one must be super easy.
Someone stuck with access tokens. They can try to explain again.
Stuck with access token, do you mean this part?
Maybe adding to collab.
Okay. First thing, you gotta have your access token ready. You must have already generated from GitHub, and it should be a classic token, not the beta version, I mean. And you have to add a secret like this. Yep. And paste your access token in this field. And allow the current collab to access it. So that this thing here can actually get it. Okay, let us know if
They couldn't see the line where to load them.
where to load them. As in
Probably, yeah,
this one here?
probably. I know the secrets in collab, I guess. Again.
This add new secret? Okay. Okay, actually 2 minutes have passed. Now I'm gonna provide the solution. And as I've mentioned, it's exactly the same thing we did in the collab. DLT.secrets.value. Same here. And that's it. I need to run this cell. Okay. The moment of truth. Let's see if it works.
We can skip the access token for next examples.
Yep. No failed jobs. Everything was loaded successfully. Yeah, and since these resources are making 50 requests, it means that in this current collab, we've made 100 requests in total. Let's go further. Now things are going to get a little bit more complicated, but hopefully not too much. Topic is incremental loading. Incremental loading means loading only the data that's been updated or changed, instead of reloading everything all over again. If you've noticed, we've been running the same pipeline, duckdb_pipeline, multiple times. And each time we've been loading the same data again and again because we didn't set a write disposition and it defaults to append. But more about this in the dedicated incremental loading collab. And here we'll cover what incremental loading is, what DLT route dispositions are, and how to perform incremental loading with a cursor field, which is going to be relevant for the main collab, so pay attention. Okay, and as I've mentioned, I'm going to repeat this sentence once again. Incremental loading is the act of loading only new or unchanged data, and not old records that were already loaded. And to understand different methods of loading, let's look at the following walkthrough. Let's imagine you have this database in Notion. This is driven some, fake startup information, so you don't have to. You go try to understand the data. This is just a database. And generally, you have three main options for how you can add data to this Notion database. Append, replace, and merge. Append would look like something like this. You have this, and you need to add a new row of data. Okay, I think this is. Whoa. Appending data. You just want to add something new, and this is the last row, which did not exist previously here. And this is appending without changing the previous one. You're just adding a new row of data. Replacing, I think, quite intuitive. You just replace the old data with new data. And merging data. This one might be a little bit confusing, but not too much. So here what happened is that you added a new row, but also you updated some entries. I guess everyone left their job and only Santiago is now left at the startup, and he's responsible for all tasks. And what you did is that you added new tasks for Santiago, because who's going to do it, and also fixed the previous data so that everything is Santiago's responsibility. So this is merge. And let's zoom out a little bit. So three options, right? Append, replace, merge. And DLT's write dispositions correspond to each one of these. And how you would define a write disposition in DLT is that you can pass it directly to the DLT resource decorator, like this. Or you can define it in the pipeline run, like this. Now you might be wondering, what if I do both? In that case, the write disposition you defined in the pipeline run will override the write disposition of the DLT resource. Meaning if this one is append and this one is replace, the write disposition will be replace. Okay. Now the first write disposition option is append. I think this one is quite easy. It replaces everything in the destination with the new data. And let's imagine a scenario where we want with Hogwarts admissions department data. So this thing here right now might be looking a little bit convoluted, but yeah, you'll You have to get used to it. So basically, we just don't pay attention to this part maybe if you're not super familiar with Python. This is just yielding data, okay? And we define the right disposition here, which is append. And we're defining primary key here, but note that when the right disposition is append, primary key is not super relevant, but we're just introducing it here straight ahead so that you get at least used to it, get used to it visually. So the add students resource corresponds to the table with the named creatures and loads data there. And it receives an input, argument entries, meaning it will yield the entries. Okay, so let's create our pipeline, Hogwarts pipeline with a destination, DuckDB, and let's give a name, Hogwarts, to our data set. And let's use the add students resource we defined earlier. In the first run here, we're adding Harry Potter. So we pass this data to the add students. Add students gets entry and yields name Harry Potter, designation student, and date started 1991, September 1st. And we see that the first pipeline node was successful. In the second run, we add Ron and Hermione together. Are they married, actually? I'm not a big Harry Potter fan, but okay. Okay, here we're adding Ron and Hermione together at once, but passing them to the add students resource, just so like we did earlier. And ran in the pipeline, and we see that it was loaded successfully again. And for the third one, we're adding Ginny, and yes, successful again. So note that add students had right disposition append, meaning right now the database should have Harry Potter, Ron, Hermione, Ginny all together. Let's check if they were all loaded. With this code, here we're using the SQL client again, and we see that, yep, all of them are there. And if we take a closer look, we can see that Ron and Hermione, they were loaded together, right, during one pipeline run. And they have the same load package ID. Okay, let's go to the next right disposition. Replace. This one must be super intuitive. So someone from Slytherin comes, I guess Slytherin and Gryffindor are enemies, and they want to delete all data from Gryffindor and replace it with Slytherin data. What they would do is, in the pipeline run, add right disposition replace, and just add the add students resource with Draco, Vincent, and Gregory. And yes, the pipeline run is successful, and let's see what happened in the database. Yep, there's no Harry Potter or Ron or Ginny, only Slytherin people. Everything was replaced. And now the merge right disposition. Okay, now we realize that Draco's date started was false. He actually started in 1991 and not 1990. How to fix it? Well, with right disposition merge. So we define the right disposition merge and provide a primary key name. What the pipeline will do is that it will look for the name Draco Malfoy, delete that entry, and replace it with a new one. We ran the pipeline here, and we see that, yes, Draco Malfoy's date started. Yeah, changed to 1991. I didn't know they were that old, though. Okay. I mean, they started school in 1991. Okay. So this, so to explain, the merge right disposition has three strategies, and the default one is delete insert. This is what happened during this pipeline run. The pipeline found Draco Malfoy, deleted this entry, and replaced it with the new one. But internally, what it does is that DLT creates a staging data set. And in that staging data set, DLT first loads the new data and then compares it with the data that is in the destination, the destination data set, finds the rows and replaces them with the new data by deleting them first and inserting. So that's what happened. And if we really check, we see that, yes, indeed, a staging data set was created, and there is a creatures table. And if we check the creatures table of the Hogwarts staging dataset, we see that there is a row corresponding to Draco Malfoy with the new date started. Yeah. Now there is another strategy, Upsert. So this one doesn't work in DuckDB, but this just for the purpose of showing you how to do it locally. The difference is that this strategy is based on primary key specifically, and it updates record if they exist in target table and insert record if key does not exist in target table. You might be thinking, isn't it the same? But the difference is that delete insert is 2 operations and upsert is 1 operation. And if we're talking about databases and cost efficiency and so on, obviously 2 operations is always worse than 1 operation. And maybe there are some permission issues also where you can't delete rows, then you would use upsert. Okay, so the last strategy, slowly changing dimensions type 2. It's used to track historical data in tables that change over time. It creates a new record for each change, keeping the old record intact, and uses timestamps to indicate the validity of each record. So before we test SD2, let's check what we have in the database, right? And we have these 3 here from Slytherin. And let's say we want to add Luna Lovegood. We'll load the Luna Lovegood data and check what happened. We see that Luna Lovegood was added, but there were additionally 2 columns created, DLT valid from and DLT valid to. What happened is that during this pipeline run, these 2 columns were created, and everything before that existed was kind of invalidated. So this is what happened. And when we run this again, meaning we're trying to add Luna Lovegood when it's already there, right? Then nothing should change. And we see that, yes, nothing changed, and Luna Lovegood, this is still valid. Okay. The last part of this current collab, I'm actually very over time, but this is relevant for the Follow Me collab, so I'll try to be as detailed as possible. Incremental loading with a cursor field is another method used to fetch only new or updated data from a data source. This is often done by passing timestamp or ID to the last record to query. The data source then returns only the new or updated records. So to explain what's happening here is that the updated argument is set to an incremental state initialized to 1970. It's configured to track the updated field in issues yielded by the GitHub, get issues resource itself. It will store the newest updated and make it available in updated last value on the next pipeline run. Alternatively, what can use is, without defining all this in the code itself, just use apply hints on a resource and say, okay, I want to make this field incremental. But note that if you use this option, the source still performs a full extract, and then the incremental hint is used by DLT to filter the data after it has been fully extracted before it is loaded into the destination. So the difference between these two is that this one fetches only new data and loads only new data, but this one fetches all data but loads only new data. Hope that was understandable, and let's go back to the Follow Us collab. Now this is a to-do part. Using apply hints, you have to make this incremental. I provided a hint because I thought this might be a little bit complicated. And there's another hint I want to tell, is that for the stargazers, you have to provide the right disposition, merge with strategy SCD2. And how you would provide this is something like this. Okay, the rest you gotta do yourself. 1 minute. Meanwhile, I'm checking the solutions because I forgot myself.
Benoit asks, scroll back quickly to the previous example. His secrets
To the collab? To the secrets?
Yeah.
Which specific part though? This here? Because it's not quite.
Yeah, and press.
Press it?
No. No, I mean that they should also enable it, set flag on.
Like this?
Mm-hmm.
Okay, to explain it again, you store your access token here, and you enable the notebook access here, meaning this whole thing can see this access token. But this code is setting an environment variable using the access token the notebook is seeing.
He wants to scroll down.
Okay. I think the time is up, right?
So this part is more important than my part, in my opinion. So take your time.
Okay, I'm just gonna start. Was this how you define right disposition with a strategy? So, okay, let's just check. Should work. Let's run this.
Oh,
Oh.
yeah, I closed the
Yeah.
parentheses too early.
What is
After created add. Yeah, here. You close to the parentheses, you should keep it open. And close it in the end.
Oh, right. And here as well. Okay.
We're learning together.
Yeah. Okay, everything runs now. Again, the moment of truth. Let's see if everything runs. Yep, successful. Let's see what happened. And the data will first focus on the issues table. And specifically, we're interested in the DLT load ID column, which identifies the load package associated with each specific data. And we see that the last load package ending with 62 is not here, meaning the last pipeline run did not affect the issues table because there are no rows associated with this load package. And this was expected because we set the initial value of the incremental field to today, and we actually already loaded everything. And since today, no new issues are there, there's nothing new loaded. This is correct. So let's check the pull requests table. Again, the same. The last load package ending with 62 is not reflected in the pull requests table, meaning the last load package did not affect the pull requests table, meaning there are no rows associated with that load package. Because, again, we set the initial value to today, and then there are no new issues from today. Yeah. But imagine a scenario if somebody created an issue like, as we speak, then we would get something. Now let's check the Stargazers table. Okay, now we see that the last load package actually affected the Stargazers table because this load package here is there, meaning there is a row associated with this load package. And let's actually check the contents of the Stargazers table. And we see that there are 6,963 rows. And we notice that the DLT valid from and DLT valid to columns were created. What happened is that during the last pipeline run, when we specified the SCD2 strategy, 2 new columns were created. And everything that existed before that was invalidated. This is why everything was loaded again. Since there are, And now we need to make sure that if we run this again, nothing will change in the Stargazers table because the DLT valid from and DLT valid to columns already exist. Unless somebody changes something in our GitHub as we speak, there shouldn't be anything changed. Let's inspect the table. And yes, 6,963 rows, same as before. The last stuff that was loaded, nothing was invalidated. This is expected. Now this is the end of my part almost. The only thing that we now have to cover is using DLT pre-built sources and destinations. So we have verified sources. They are tested regularly, meaning there are base projects you can build on. These projects are initialized with DLT init, verified source name, and destination name. I hope you're already seeing the tech stack you're using. And what you would do is install DLT with DuckDB. You can also list all verified sources, and this will show all available verified sources and their short descriptions. And for each source, it checks if your local DLT version requires an update and prints the relevant warning. Example, we can run DLT init Pokemon.db, which uses the Pokemon API verified source with DuckDB as destination. What this will do is this will create a project which will have this structure, the Pokemon pipeline, the Pokemon folder, which has the verified source code, and the .dlt folder, which has the config files that we've covered earlier. And what you would normally do with this page-based project is that you add your credentials to these two here, adjust the pipeline script here as you need, and run the script with Python Pokemon_pipeline.py, and that's it. And in certain cases, if you're familiar with Python, you can adjust the source code. Easy as that. This is just an example how you would run your pipeline, query your database, and see the information. And in terms of destinations, honestly, this is just a matter of checking out our documentation page. I think everything is quite straightforward. So yeah. And by now it should be, it must be quite intuitive how to choose a destination. What you would do is that you would just change this name. So instead of Snowflake, you, for example, choose DuckDB, or instead of DuckDB, you just define Filesystem, and so on. Easy as that. But if you're using specific destinations, do not forget to provide credentials. And for each destination, there is documentation on how you can provide the secrets. For example, ClickHouse here. Yep, that's it. Now, slowly transferring. Is transferring the right word, given up the stage too? I don't know.
Sorry. Oh, I unmuted you. So it was first part of the first part. So we still continue. So our next topics will be, let me share my screen. So the next topic would be DLT destinations. For example, you could think that DLT able to load data only from API response to database, but it's not true. You can load data from Filesystem to database, or you can load your API response to Filesystem, or you can load the data from one database to another database. So DLT is quite powerful. It has a lot of helpers for this purpose. Can you see my screen? Okay, good. So let's start with the DLT file system. We will talk mostly about destination, but also I will show you how to use file system source as well. So we're going to use the same example as Anun used, so our GitHub API data. So we set pagination as we usually do. We use while true loop, response data, checking if we have next page, and until it's there's no next page. Yeah. And then we define resources as we did in previous part. issues, stargazers, pull requests, and set our credentials, or we can skip because GitHub doesn't require credentials, but it limits your requests. So then we group our resources in one source, define pipeline. So you should be familiar with it. It's already something you know. And then we run pipeline, check load info. It was successfully loaded. And we decided that we don't want to have our data in DuckDB. Yeah, we are, for example, machine learning engineers, data scientists, and we prefer working with files, CSV files, Parquet files, JSON files. What we should do? First, we should install DLT with requirements, with the extensions. We call it Filesystem. Just run pip install DLT Filesystem. Then you should set bucket URL. In this example, I will show you the local experiment. Yeah, so we set bucket URL as our local folder. This folder actually is content. We check it with CLI command, command line command. Okay. But as Anu mentioned, it doesn't work well with Colab notebooks, so we're going to use environment variable. As you should remember, to set environment variable for DLT, we should use a double underscore. So your environment variable should have the next structure: destination, double underscore, file system, double underscore, bucket URL with single underscore, and and set the value. What difference between loading data to DuckDB and file system? In this case, we just need to replace destination from DuckDB to file system. That's it. So our configuration is we set bucket URL and change destination to file system. Then we load pipeline, load our data, run pipeline, and see. Yeah, it was loaded. I could run it, but it takes a lot of time. Okay. So we can see that many folders were created, and each folder contains JSON files. So we also can control our layouts. So we set environment variable, as we usually do, destination file system layout, and set what type you want. In this case, we added timestamp. So you can see, if you run the pipeline again, you can see that your files will have the next naming. So it's load ID, so file ID, and timestamp. Okay, then we decided that we prefer CSV files. And we set environment variable as a normalized loader file format and set CSV file. Also, I put here some extra configuration. We disable compression, because if you do not set it, your data will be compressed and you cannot read the data in UI. So you need to unzip it first. Okay, let's load our data. It was loaded, good. And now our folders, our table folders, for example, issues, they have CSV extension. Okay. Okay. What if you want to use not local file system, but just Google Cloud Storage or S3 bucket as a storage? So the process is similar. You set your bucket URL, You set credentials, of course. You should install DLT extension. With, for example, for Google Cloud Storage, it should be GCS. Also, you can set your credentials in the same way using environment variables and just run your pipeline. So you already set destination as file system, set pipeline name. You can set also dataset name. That's the name of your schema. By default, it takes your resource name or source name. So it will be GitHub data. And yeah, that's it. Let's talk about file system source. What it is. Yeah. So you can load your data not only to file system, but also you can parse your files and load them to database, for example. Or you can move your files from one file system to another, from local to S3, from S3 to Google Cloud Storage. DLT from last week, probably, so we had release 1.0. DLT moved file system source to the core, so you don't need to initialize the source anymore. You can just import it from the core, like this. So then we set up the source. We provide bucket URL. So it's a folder. We want to read your files. I picked our tables from the previous step. Here we loaded our data from GitHub to local file system. And now I load our data from local file system to DuckDB, to another destination. So we pick all CSV files from issues folder and load it to the DuckDB. In this case, we load only one table, issues, because DLT will create only one table with a name, in this case, table name. Yeah, we can put any name for table. So define the pipeline, run the pipeline, and see what was loaded. So DLT loaded 163 issues to DuckDB. So that's how it works. That's it about the file system destination. Let's go to follow us collab right now. We're gonna do small task. Let's. I will run the pipeline. You should run it before. Oh, it's just connected. Okay. So I ran my GitHub resources. You should have it in your follow-up collab as well. And the first task will be set up environment variable bucket URL to content. So I did it in a previous collab. You should just try to repeat it. As you remember, you should use same structure, and each word should be split by double underscore. So I give you a minute to do that. So any questions or comments here? Okay. Do we have viewers? Okay, good.
People who are,
Hmm?
people who are leaving, people are gonna find you. Just kidding.
Yeah. Okay, let me help you. So we put first destination, then double underscore file system double underscore bucket. In this in bucket URL we have only a single underscore URL, and here we set content. Let's run it. So content, it's our current working directory. It's this directory. Okay, let's go further. Now you should create a pipeline with a file system destination. You should remember what I told you, what you should change in defining DLT pipeline. So what should be different? What's missing? I give you 1 minute to finish it. Can you show me the video? Because I want to check. Oh, shit. I need to check the layout to make. Yeah, that should be better. If it's not better, let me know, please. Oh. Okay, let me help you. Now, so we should set destination, of course. Destination, in our case, it's file system and comma. So now we can run this cell and run the pipeline. Try to run it as well. Okay, it works. Good. You could notice I use dev mode true. What does it mean? It means that DLT takes your dataset name. In this example, we do not set dataset name explicitly, and DLT takes your source name by default. Also, DLT. Let me check. System. Yeah, pipeline name, variable name. No, something. Okay, it should take source name. Okay, I think it's dataset name, destination name. Oh my god, and dataset, just as a constant word. And this you can see it's a timestamp. 2024 September 19th. So it means that DLT on each run it creates new data set. Okay, let's go further. Let's look at our data. So we have content. Okay. We should set root path. Okay, you can see your data set with all loaded tables. Each table it's a folder, and each folder contains JSON, a list of JSONs, and that what I was talking about. You can't read it yet. It's it means that your data was compressed, and to uncompress your data, you should set disable compression equal true. So let's do that. So it's the next task. Let's disable the compression with using the environment variable. I'll give you 30 seconds. Okay, let's do it. Normalize double underscore data single writer double underscore disable compression equal true. Let's run it. Normalize data writer disable compression looks correct. Let's define our pipeline again. Run the cell because DLT should create another pipeline and run it. Okay. Let's look at the data. We have now two data sets. That's what I told you about dev mode. So on each run, DLT creates a new data set. If you have same pipeline name, it creates a separate pipeline with different data set name. So the difference is in timestamp, of course. So now we have another time, and let's look into the data. So okay, now we can read our files. They unzipped. Okay, it works. Okay, now I will show you something really interesting. We're gonna use Filesystem as staging. You can ask why we should use Filesystem as staging. The goal of staging is to bring the data closer to the database engine so that the modification of the destination dataset happens faster and without errors. So DLT can create two staging areas. Staging dataset, it's used by merge, as Anund showed you. So it creates the duplicated tables, yeah. And staging storage. So it will load your data as files in your storage, local or cloud, any you want. No, we cannot use local staging staging storage. Yeah, only cloud buckets. Yeah. Let's go to the example. Okay, I already have it here. Reconnect, install. Okay, let me tell you again what is staging storage. Imagine you load your data from A to B. A could be API response, and B is your database, Postgres database, for example, or BigQuery. And when you load your data, DLT processes your data in 3 steps. It's extracts data, normalize data, and load it. You can run it directly from A to B, from one machine to another, or you can also use staging. So it means that first 2 steps, like extract and normalize, extraction and normalization, they will be done on local machine. Then your data will be loaded to cloud storage as files. And then the load step, the third step, will be done directly from your cloud storage to database. From, for example, Google Cloud Storage to BigQuery. So they are so it reduces errors to make it faster and more reliable. So in our example, I will show you how to load your data from GitHub to Redshift, and we're going to use S3 bucket as a staging. So first, we need to install DLT with extension Filesystem, then extensions for Redshift. We set our access token for GitHub. You can skip it also because it's not necessary for GitHub. Add S3 credentials. S3 credentials we set same way as GitHub token, so as environment variables. And yeah, we're gonna use same example when we're loading our GitHub API data to the destination. Let's run it. Okay, define the pipeline, set the name, set the destination. First, First, we load our data to the local, or to the cloud storage, S3 storage. Set dataset name. It's our folder name. In this bucket a bucket name, yeah, I would say. Define the pipeline, run the pipeline. It takes a while because it's loading data to S3 bucket. So, okay, let's go to spoilers. So that's how your data will look like in your bucket. So it was automatically created by DLT. It's your dataset name, as you remember. So yeah, it's done. It's loaded to this bucket. Yeah, and yeah, all tables are created same way as they were created in local file system. So each table it's a separate folder. Okay, let's try to load the same data to Redshift directly. We set our credentials as follows, using environment variables, or I used just one string credential. It has this format. So set credentials, run the pipeline. You can see that in this case, destination will be Redshift. So I load data directly to Redshift. Okay, it was also successfully loaded to our CI test database in Redshift. So yeah, you can see it was successfully loaded. And now we're gonna try to load data to Redshift and use S3 as a staging. So for this purpose, we just set staging parameter as Filesystem, destination as a Redshift, and runs a pipeline. So that's it. So now this run method will load your data to S3 as files and load your data from S3 to Redshift directly. Yeah. Using DLT. Really, it's that simple. Okay, just imagine it was loaded and go further. Let's come back to our Follow Us collab. Actually, for this section, we do not have to-dos, so take a breather. I just keep this example here. You can play with it later after workshop because you need to set up Redshift, S3, and so on. It will take a while. So let's go further. you would ask me, Alona, what is the most difficult in building pipeline? And I would say the most difficult is to make it work. Yeah. So we have like many helpers which can help you debug your pipeline. For example, you can first inspect your schema. Yeah, what's wrong with your schema? Or you can adjust your schema. You can change it. You can modify it. Let's go to this section and look how to do that. Okay. We use the same example with GitHub API data. We load issues to DuckDB. Okay, run the pipeline. And now we want to see the schema. Yeah, what was created? Because on the first run, DLT will check your data, normalize it, create schema, and load your data to database. Yeah, and you can see if you run this command DLT pipeline name, and load package command, you can see the whole information about the loading process. Also, this small argument v can show you your schema updates. It will show you what tables were created, what columns were created, which data types they have. So yeah, you can see the whole schema in here. On the first load, all schema were created. So DLT will show you the whole schema. But if you run it the same pipeline again, and for example, if you have incremental loading for your pipeline and you load only new data, nothing will be changed. So it will be empty. So, okay. Alternatively, you can inspect your schema with Python, which is very convenient, in my opinion. Let's look to load info. Load info, it's something we always printing. Yeah, you could notice that when we run the pipeline, we print something, and this load info collect and contain the whole information about your pipeline loading. Let's come back. For example, load info contains all your load packages. Load packages usually they are just one load package. Yeah, so it collects your data about your source. You have usually one source. DLT load it as a one package. So that's why I use 0 here. Each load package has many attributes and methods, but we will discuss them later. Now the most interesting for us is schema. Schema is also not just not simple attribute. Yeah, it also has its own methods and attributes. Let's look at them. This schema has this amount of additional methods and attributes. You can see them. Yeah. Currently, we are interested in to pretty JSON. Let's print it as a pretty JSON, and we can see the whole schema here. Here we can see all tables we have. You could notice this DLT with underscore prefix tables. They are after generated by DLT because it has to keep all your states, all additional meta information to make your pipeline more powerful, more reliable, more robust. Also, you can find here all information about your tables. Yeah, what Redis position it has, what the resource name it has, or even description. It's another after generated table. And yeah, now we can see our GitHub tables. Currently, we have one parent table, issues, and oh my God. Yeah, it has it has a parent right disposition. Resource name is get issues. Another auto-generated, yeah, and it has several child tables. They were also auto-generated by DLT. DLT automatically unnests all your data. You can control the level of unnesting, but by default it unnested for like not infinite. I think it has some limits, but yeah, but trying to unnest it fully. So here you can see table name, columns it has, data type, and properties. Okay, also each table contains some DLT weird columns with again underscore and DLT prefix. They also auto-generated. It contains unique IDs for each row, and also if it's child table, it contains parent ID. Okay, let's go further. Another way to see a schema is to export schema. To export your schema to YAML file, you should just set the parameter export schema path, and here is a path to the folder, which will contain your schema YAML. So skip it. Yeah, schema YAML will have same structure. It contains your version hash. So each time your schema changes, your hash changes. So it's based on the content hash. Also, interesting part is settings. You can change them. For example, by default, DLT put after detections for timestamps. If DLT think that your data has timestamp data format, it automatically transform it. Also, you can add more detections. Here, like large integers, hex bytes to text, way to double, and so on. Okay, let's talk more about hash. Your version hash always stored in your destination as well. So you can export your schema as YAML. You can see it as a Python object, yeah, but also you can find it in your DLT version table. So DLT version table, it's also auto-generated table by DLT. It contains all your schema information, including hash, including schema. Yeah. So it's too advanced. Let's skip it and talk about it in the part 2. So the next very important part is how to modify a schema. For example, if DLT after detected your data with wrong data type and you want to change it, the first way to do that is to set it explicitly. When you define your resource, you set columns and just enumerate them here with proper data type you want. If you already use prepared resource, for example, some verified source, and you do not have access to these parameters, you can use apply hints. For example, yeah, we use some MongoDB verified source. We don't want to touch source code. We want to modify it on a high level. So let's define the source and apply hints for each resource in this source. So it has same structure as for DLT's resource decorator. Just apply hints and enumerate all columns you want to change here. Okay. Also, you can control your schema with Python. For example, you can remove some detections I told you about already, or add them using Python. So this is very convenient in my opinion. Another way to change your schema is to first export your schema to YAML file and then import it as a file. For example, yeah, that would be cool to run it. Okay. Okay. You can export your schema to YAML file, change anything you want, data types, settings, some defaults, and import it. Very important to put your changed schema into import folder, not export. Export doesn't change anything. Yeah, it's just DLT use it to export the schema. So that's it. Let's see what we have in our follow us collab. Oh, let's look how our schema export and import works. Let's run this cell and load our GitHub data from previous steps, as usual. Yeah, it was successfully loaded. Let's see what we have. We have schemas folder. Here we have two folders, export. You can see our schema as YAML file. And also we have imports folder. We have absolutely the same YAML file, but this file we can change. We can change the we used file system destination. That's why we do not have columns in our tables. But if you use DuckDB, it would have all columns and data types for columns here. But what we can change, we can add description in here. So the next task is to open the schema in the schemas import folder and add the following descriptions to the issues, pools, and stargazers tables. Because without descriptions, tables are just misunderstood spreadsheets waiting for their moment. So I'll give you a minute to add your descriptions to import schema. So do they have questions, comments, something I should know? Okay. Also, if you have some very difficult questions or you want to learn more about DLT and support in our chat is not enough for you, ask your question in Slack. It's much easier to track your questions in our Slack community, and also we can ask them late or answer them later if we don't know the answer right now. So So don't be shy. Ask right in the workshops channel right here. Okay, let me add the descriptions in our YAML file. So let's find issues table. Just type description and copy paste it from here. What next? Pools. And stargazers. Save your file, don't forget to save it, and rerun the pipeline. Oh my God, that's why we need access token. I got rate limit exceed. I can use it directly here. Let's rerun it. And look into our export YAML. Yeah, export contains all your schema with all columns and data set, data types and so on. Yeah, we can see that export schema now has correct description for our tables. So it works. We updated our schema. Okay. Check also your export folder and check if your schema was changed. Okay, now we've almost finished our workshop. The last, and in my opinion, one of the most important section is understanding pipeline metadata. Why it's important? It's important to understand why your pipeline doesn't work or work not as you expected. So let's dive into DLT pipeline inside. Okay, we use GitHub API example to load issues around the pipeline, around the data. As we talked about load info before, and it's very powerful object. You can find not only schema in there, but also you can find all information about the loading process. Yeah. you can find the name of pipeline, the location of this pipeline. You can find the package name. You can find the location of this package name, yeah. You can find details about jobs, what tables were created, what file type, yeah, size, when it started, when completed, how long it take. Also, you can check particular package. For example, if you want to check the previous one, yeah, by default, it shows you the last one, the last load package. If you want to check some old one, you can explicitly set the number of load package. Okay. As you remember, load info has many methods and attributes you can use for debugging your pipelines. For example, you can get the same information as you get from the load package CLI command. You can get it using Python. Just print your load packages. Let's see what methods and attributes has load package. Not as many as Schema has, yeah, Schema. Also, you can look at your load info as a dictionary, or you can check when it was completed. You can check what jobs were loaded or completed. You can check schema and, of course, state. Okay, another way to check your pipeline details, use trace. Trace is a detailed record of the execution of the pipeline. It provides rich information on the pipeline processing steps: extract, normalize, and load. As I mentioned, DLT works in 3 steps. First, it extracts data, it normalizes data, and then it loads it. So let's look into GitHub issues pipeline trace. Here you can see step extract. It was completed in 1.5 and 50 seconds. We can see the load package number, and there's information that data was loaded, extracted but not loaded. Next step is normalize. It provides also information about your normalized data, how many tables were created, how many rows were added here. And also we can see that data was normalized, but not yet loaded. And the last step is load. It takes the most of time, usually. And it's our old good load info logs. Yeah, and step run, when you run your pipeline with run method, like pipeline run, DLT call is step run. So altogether, it took 8 seconds. Okay. We also can check this trace via Python. So let's just use last trace for pipeline. And also this last trace has extra information about each step. For example, it has information about extract info. We already could see it here. Extract, yeah. If you run last extract info, it will show you just info about extraction. Same for last normalize info. It shows you last normalized data, how many tables, how many rows in here. And last load info. It's our load info print, as you can remember. Also, normalize info has extra method, extra attribute. It just returns how many rows each table has as a dict. Yeah, so you can use it for tests, for example. Let's talk about state. it's another very, very important part of the ELT pipelines. So pipeline state is a Python dictionary that lives alongside your data. So this state will be automatically created by DLT, and it will be stored on your local machine or machine when you run your pipeline and in your destination. For example, if you load your data into database, it will be stored in your database. New database. Okay, how to look to your state? You can use CLI command DLT pipeline name and info. We use a V option to get more information. So it's verbose. It's very useful command. You can see the main information about your pipeline as a pipeline name, pipeline location. You can see the dataset name, schema names, so you can have several schemas. You can check your destination type, destination name, and your schema hash. Also, here you can see the dictionary, and this dictionary is your state, actually. It's just a dict. So here you can find several levels. You can find a pipeline level, a resources level, a particular resource level, for example, get issues. GitHub data, it's source level, yeah. Source level, resource, and each resource has its own state. For example, get issues, we created get issues as an incremental. Here you can see that get issues is incremental resource, and DLT uses state to keep your last value. In there. So here you can see your initial value, last value, also unique hashes for updated at cursor. So what else it has? It has information about last extracted at when it was ran. It was ran yesterday. Also, what tables it has, how many columns, yeah, and yeah, that's it. So let's try to look into this state using Python. So as I said, state it's just a dictionary. So it's we store it as a JSON file in your machine when you run the pipeline and as a part of your destination. If it's a database, it's a part of your database. If it's a file system, it's also several JSON. It's separate JSON. Well, let's read this JSON and look what inside. So inside we can see the pretty much same information. Last extracted, schema name, pipeline name, destination, and our sources state. We can also control the state, but we can't control it outside of resources and sources, but we can use it inside of resources. For example, when you define your resource, for example, get issues, you can call the resource state, the current resource state method, and take any value you want. For example, as you remember, we have get issues resource, and it contains incremental key and an incremental key. It's also a dictionary, and it contains updated at as a cursor, so we can get our last value from this state like this. Also, we can create new key, customize our source, our state, and make it and use it for any purpose you want. For example, yeah, we call DLT current resource state, set default new key, and set the value. It could be anything. It could be just a number, string, or a list, or anything you want, any Python object. Yeah. So let's look how it, in our state. So imagine I ran this pipeline and read the state. Here we can see our sources: GitHub data source, our get issues resource, and get issues has now two keys: incremental and new key, our custom key. You can use it to store important information, but very important, don't try to store your data, your data you want to load to destination, because this file can grow too quickly, too much. What else we can do with the state? Yeah, for example, we can set some condition. Yeah, in this case, we want to change our value. So we set new variable as a so new key. And if something happened, new keys appends with some third value. Also, we can change our incremental dict. Yeah, we can update it with second new key. Let's look at the state. So now we get issues. Our resource has two keys, incremental and new key, but incremental has also two keys. Before it had only updated add, but now it has also second new key, our custom key. Yeah? And also we have updated new key here. So you can do the same for source level state. For example, you can change it the same way. And you can see that your sources, GitHub data source, now has two keys as well. Not only resources, but also source new key. It's very helpful if you want to share some values between few resources, yeah, and the frames on one source. Okay, as I told you, DLT saves your state in two places: on your machine and in your destination. And of course, you can sync your states. For example, if you know that if you load your data from several machines to one destination, and you know that your destination has the most updated information, you can sync your state from destination to machines. So you can use sync command, DLT pipeline sync. Yeah, that's how DLT pipeline state table, one of the automatically generated tables, how it looks like. Yeah, so it contains a pipeline name. There is our state, it's just a hashed full state, and some additional information. Okay. Also, you can reset. So that's it. So that's it about technical materials. And let me tell you last words about what's new in the DLT world. I want to share with you what we're working on now. So as you know, DLT is all about efficiency, and for developer and for the infra budget. And in this spirit, we present the data pond. I should probably, share it like this. I love this picture. I guess Adrian created it. So here you can see the DLT. It's a pipes to your pond with your files. Yeah, it's a small data lake. So you store your data as a Parquet files, for example, and you can apply dbt models on it, so you can transform your data. And after that, you can use DLT to load your prepared, clean, transformed data into a very expensive warehouse like BigQuery's Snowflake and so on. So there's a lot of very smart words. I think we already are very tired. And I just want to tell you that this data pond thing, it will be our main paid feature. So if you're interested in it, so feel free. So for example, if your previous pipeline looked like you store your raw data, then you move it to data warehouse, then you transform your data with dbt models, load it again to data warehouse, and you want to change it, for example, to taking your raw data, move it to data pond as some storage, cloud storage, for example. Apply all modification on this data right away, and only then move your data into data warehouse. So let's just call us, okay? So the next cool feature of DLT, it's DLT for teams, because we know that usually companies has the whole data teams to control their data, and sometimes you want to run your pipelines and you want to share it with your colleagues. You want to have the same environment for all of you. So some entry point for all data engineers in your team. So DLT currently working on this workspace for teams. And the next thing is DLT introducing the DLT project format. So DLT wants to provide you building blocks to build your data platform. So these project formats you can use as they are, of course, completely okay, so you can use it as a building blocks to build your data platforms. So why would you need DLT for teams? Yeah, so it would be schema-centric collaboration. Okay, I don't want to read it, honestly. Let's go quickly. Low code, high power. Okay. Contact us. Contact sales. If you're interested in building blocks for data platforms, if you're interested in data ponds or DLT for teams, just contact us in contact sales on website or in our community Slack. Just feel free to communicate with us. I think that's it, guys. Thank you for your attention. 22 people survived. Oh my God, I have to stop sharing. Okay. And want to tell you thank you and see you next week. We have part 2. It's a very interesting part. We're going to improve our pipelines performance. We're going to customize our incremental loading and try to deploy our pipelines with Duckster and something else. Yeah. So see you.